This video is for review quiz 1.6, which is on other types of equations that we solve. This first problem is talking about solving this polynomial equation by factoring and then setting each factor equal to 0. That's what the zero product principle is. So first thing I'm going to do is I'm going to get it all over to one side of the equation. So 64y cubed, 64y cubed, and then I'm going to subtract the add the 128y to the other side, so it's with the 64y cubed. So it's going to be add 128y squared. Then I'm going to subtract the y over to the other side, so it's also with the other stuff. So subtract the y, and then finally minus 2. And that will now all equal 0. So I moved everything on the right-hand side to the left-hand side. Now I can factor by grouping. That's how we can factor cubic polynomials by hand. So looking at the first two terms and then looking at the second two terms. The first two terms, I can take out a 64y squared. So 64y squared. And that will leave me with y plus, and then 128 divided by 64 is 2. And then, of course, I took out the y squared with that. The next two terms, because this is a negative, I'm going to take out a negative, and then the most I can take out is -1. So I'm going to write -1. That leaves me with a y plus 2. And these two things in parentheses are the same, so I've done it correctly. I get 60, let's do it this way. I get y plus 2, and then 64y squared minus 1. The 64y squared, that can factor further. It's a difference of two squares. So I'm going to factor that down. 64y squared is the same thing as 8y squared, and the 1 is just 1 squared. So I get 8y minus 1 and 8y plus 1. And now I have all my linear factors. The zero product principle just says that this thing is 0 when each one of these things equals 0. So y plus 2 equals 0 when y equals -2. 8y minus 1 equals 0 when you add 1, and then you divide by 8 when y equals 1/8. And 8y plus 1 equals 0. You're going to subtract 1 and then divide by 8. Subtract 1 and then divide by 8. That's going to be when y equals -1/8. So those are our three answers. I forgot this one actually has a couple parts. So it says rewrite the equation in factored form. So in factored form, we have y plus 2 and 8y minus 1, 8y plus 1. The solution set then is going to be -2, 1/8, and -1/8. Make sure you have commas between them. Let's check it, and that's all correct. All right, the next one is a radical equation. All we're trying to do here is just simplify this thing down. And remember, when you're doing radical equations, you need to make sure that you check your answer. So a lot of times you add in an answer to this when you shouldn't. So first thing I'm going to do is get one of the radicals by itself. I'm going to get the x minus 2 by itself, so I'm going to subtract this thing over. The reason why I'm doing that is I think it's going to be easier. It's probably not. It probably doesn't matter which one you do first, but I'm just going to try it this way. And now I can get rid of the radical by squaring. So make sure you square both sides, all of both sides. The square and the square root cancel, giving me x minus 2 on the left-hand side. On the right-hand side, I can expand this into two of these things and then FOIL it out. I get 4. 2 times negative root 2x plus 3, and then we have negative root 2x plus 3 times 2. Those are like terms. They're going to add. That's going to give me 4 times root 2x plus 3. If you're confused about that, just expand it and then combine like terms, and you'll see you get the same thing I do. And then we have negative root 2x plus 3 times negative root 2x plus 3. That's going to be positive, and then the root times the root, they're the same thing, so it's going to be squaring it. In other words, the square root cancels, and we get just the inside. That pretty much always happens that way. Now I can combine like terms. Let me clean this up just slightly. And combine like terms, I have 4 and 3 equals negative 4 root 2x plus 3, and then plus 2x. 4 and 3 is 7. And now I can subtract it to the other side to get the radical by itself. That'll give me negative x minus 9 equals negative 4 root 2x plus 3. I'm sure if I did this the other way, it might be a little bit nicer, I guess. Maybe not. I don't know. But this one I can keep going because I can divide by negative 4. Divide by negative 4. That's the same thing as dividing each of these things by negative 4, because the division of negative 4 distributes. So I can have negative x over negative 4, and then I'll say a minus 9 over negative 4 equals root 2x plus 3. Before I take care of this thing by squaring it, before I do that, I'm going to simplify this left-hand side. Negatives cancel and these negatives cancel, giving me x over 4 plus 9 over 4. Nothing can simplify further there, so I'm going to leave it that way. And I can square to get rid of the square root. Okay, that leaves me with 2x plus 3 on the right-hand side. And then on the left-hand side, I have x over 4 plus 9 over 4 times x over 4 plus 9 over 4. Doing the whole foiling this thing out. Let me move this down a little bit. Give me some more space here. The first two gives me x squared over 16. Then these two and these two are like terms, so it's going to give me. I'll just write this one out. It's going to be a little bit easier, I think. 9x over 16. X times 9 is 9x, and then 4 times 4 is 16. And there's two of them. And then finally, we get 9 over 4 times 9 over 4 is 81 over 16. Okay, these two are like terms, so we get x squared over 16 plus, they already have common denominators, so I can just add the numerators. We have 9x plus 9x, that's 18x. 81 over 16. And now I can multiply out a 16 to get rid of a fraction. If I do that, it's going to be easier to work with. The numbers are going to get larger, but I think it'll be better. So I'm going to multiply everything by 16. That'll get rid of the fractions. And of course, the 16 distributes. So we get x squared plus 18x plus 81 equals 32x plus 48. This is a quadratic equation, so I'm going to solve this by getting it all over to one side and factoring. So I have x squared minus, let's see, that's going to be, I think, 14x. 81 minus 48, it's 51, 31, so I think it's going to be plus 30. It's 33, I think. Up 3, yep. Okay. Now I can factor this thing. We have a times c on top is going to be 1 times 33, and b on bottom. Two numbers that multiply and add, well, that should be just negative 11 and negative 3. That's really the only combination you can have that multiply to give 33, besides 1 and 33, of course. And that works out. So this thing factors directly into x minus 11, x minus 3, because a here is 1. That means we can immediately do this. And of course, I get two answers. I get x equal to 11 and x equal to 3. Now I have to check this. So let me go back to the original problem. This one was a long one. This is the original problem. And I'm going to plug my answers into there. So the first one is 11. So let's plug in 11. Get my red. Plug in 11 in there. And that gives us, I'll just do it in red, 22 plus 3 is 25. 11 minus 2 is 9. That gives me 5 plus 3. And this is incorrect. 5 plus 3 is 8. So we must exclude that answer. Now let's try 3. So I got 2 times 3 plus 3. And then 3 minus 2. 2 times 3 is 6, plus 3 is 9. This is equal to 2. 3 minus 2 is 1. I must have done something wrong here. Let me check real quick. No, I didn't do anything wrong. The reason why I checked that is because 9 squared, the square root of 9 is 3, and the square root of 1 is 1. And 3 plus 1 does not equal 2, which means that this answer is also incorrect. Both of them do not give us a true solution. So what this means is that we don't have any solution, and therefore the solution set is the empty set. In other words, there is no solution in the set, in the solution set. So we check that. It does give us 100%. So we did it correctly. Actually, while doing this, we added 2 solutions into it. So you definitely need to check. What that means is that this original equation is never true. There's no x value that can go into there that can make it true. It's always an incorrect statement. All right, the next one is rational exponents. And remember, the important thing here to note is that if we are getting rid of an even power in the numerator, if we're getting rid of that, we must add a plus or minus in the answer. If it's not, we don't have to worry about it. It's going to give us one answer. Here we have an even power in the numerator, so we do need to consider plus or minus. If you're unsure of that, make sure you watch the lecture video. I talk about why that's the case. So to solve this, I'm going to take this to the power of 3 halves. 3 halves. And I must add a plus or minus because I have an even number in the numerator. 2 and 2 cancel, 3 and 3 cancel, gave me just x minus 2. And this equals plus or minus 3 over 2 is the same thing as the square root of 9 cubed. The square root of 9 is 3, and 3 cubed is 27. Now I can split this up into 2 equations. X minus 2 equals 27, and x minus 2 equals negative 27. Doing the same thing on both gives me x equal to 29 and x equal to negative 25. So there are our 2 solutions. Plug those things in. See if we get 29 and negative 25. And those are correct. Okay, here we have an equation, and what we're trying to do is figure out, can we write this quadratic in form? It might not stand out to you that this is quadratic in form. That takes a little bit of practice, but for now we can see that it says make an appropriate substitution to rewrite it into an equation of quadratic form. So it's telling you that it can be. The question is, what's the substitution that we do? Well, what I'm going to redo or rewrite is this square root. I'm going to rewrite this square root as 1/2. And then I'm going to write this x. X is the same thing as x to the 1. And now you might be able to see how it is quadratic in form. That's because x equal to 1/2, if you multiply this power by 2, it's going to give you 1. And that's typically what you have. You have x squared and then something, ax squared plus bx plus c. We have 1 multiplied by 2 gives me 2. So that's kind of what indicates to you if it's quadratic in form, if you can do that. And we can here, if I just make the substitution that u equals x to the 1/2. Because now I get x to the 1/2 here just becomes u, so I get negative 14 u plus 45 equals 0. And if I square u, that's the same thing as squaring x to the 1/2. Well, x to the 1/2 squared, you can multiply the powers. 2 and 2 cancel, 1 and 1 cancel, that's giving you x. So u squared is equal to x. That's what x is right there. So we have just u squared. And now we do in fact have a quadratic. Typically what it will help you to do, if you're confused about this, is look at whatever is this term, not the highest power, the middle power there, not the number by itself either. Look at that term and make the substitution based on that and see if this part satisfies the rest of a quadratic. If it does, you are good to go and you can simplify it. So I'll just keep this out because that's going to be the first part of this portion, x to the power of 1/2. The quadratic equation is going to be u squared minus 14u plus 45 equals 0. Now all I need to do is solve this how I normally would. So I can factor this AC method, a negative 45 and negative 14. Let's see, that gives us, I believe, negative 9 and negative 5. This is actually a positive. That makes it all work out correctly. That gives me the factor of u minus 9 and u minus 5 equals 0. So we get two answers. We get u equal to 9. That's, I should say it this way. I should say u minus 9 equals 0. That implies u equals 9. And then u minus 5 equals 0 implies u equals 5. But of course, that wasn't what we originally started with. We started with x, and u equals x to the 1/2 power. So x to the 1/2 power equals 9. That's the same thing as saying the square root of x equals 9. So to solve it, all I have to do is square it. So x equals 81. And then the square root of x equals 5. Square it. We get x equal to 25. Those are the two solutions for this equation with x, not with u, right? With u, it's 9 and 5, but we didn't start with u, so we need to make sure we end with the same variable we started with. Check it, and it's correct. All right, last problem. We have an absolute value equation. And the most important thing here is to get the absolute value by itself and then split it up into two equations. If you don't remember, that's because absolute value has two directions you can come from on a number line to get to a point. The distance away is, there's two directions you can go, so there's going to be two answers. Okay. First off, I'm going to solve for this thing. I'm going to do that by subtracting 12 and then dividing by 4. That's the next step. Okay, divide by 4. It gives me 6 minus 3/2 x equals 3. Now I have the absolute value by itself. I can split this up into two equations, the positive and the negative. So we have 6 minus 3 over 2x equals positive 3, and 6 minus 3 over 2x equals negative 3. Okay, now we can solve this. Subtract 6. It's really the same process for both equations, so I can just do them at the same time. Negative 9. Now I can get rid of the negative 3/2 by multiplying both sides by negative 2/3. That will cancel with the 3/2. The same thing on this side, so negative 2/3 there. So the 3's cancel, 2's cancel, and the negatives cancel. That proves that you'll get just x here. Now here we have negative 2/3. So these 3's cancel, this is over 1, and the negatives cancel, giving us just 2 over 1, or 2. On this one, let me move it over just a little bit. Of course, the same thing happens on that on the left-hand side. Now we have 9 over 1. This 3 cancels with that 3. And we have negatives canceling. We have 3 times 2. In other words, x equals 6. We have two solutions, x equals 2 and x equals 6. Let's check them. 2 and 6. And that's correct.